In this video, we are going to be going over worksheet VL-1032, which is the distributive property homework assignment. So I'm going to help you get started on this. Let's begin. In the first section, they want us to write an algebraic expression for each verbal expression below. So I'm going to do number 3, and it wants us to double the quantity of 6 and a number. Now, doubling something means you're going to times it by 2. So if I run a mile a day and I want to double it, I would run 2 miles. Or if I run 5 miles a day and I wanted to double it, I would run 10. So you're multiplying it by 2. So it's 2 times something. Well, 2 times what? Well, you're 2 times the quantity of 6 and a number. 6 and a number. Quantity is like the amount of 6 and a number. 6 and a number means it's 6 plus some number. Now, we don't know what that number is, so we're going to use a variable. You can use x or y. I'm going to use n as my variable. And 6 is just 6, so you could just say double the quantity of 6 plus n. So how do I double 6 and n at the same time? Well, I could put 6 and n, the quantity of 6 and n, I could put it inside a little package or parentheses. And if I want to double the whole thing, I just multiply the whole thing by 2. So 2 times 6 and n, so you would end up having to distribute. But yeah, when you double that, you would do that for the rest of these. 4 times a number plus 2 multiplied by 9. Now this gets a little bit tricky. 4 times a number plus 2 multiplied by 9. So try your best on that one. And then for number 5, let's look at this one. This is like a longer word problem. The dance teacher packed students' gear for the recital. Okay. Each student needed 3 costumes and 2 pairs of shoes. Write an algebraic expression to represent how many costumes and shoes were packed if there were 10 students. Well, let's see. 3 costumes and 2 pairs of shoes. Well, we got to come up with something that represents 3 costumes. How about C for costumes and S for shoes, for pairs of shoes, or P for pairs of shoes. So how about each student needed 3 costumes and, or plus, 2 pairs of shoes. So 2 pairs of shoes. Now, if we need to write an algebraic expression, or 2 algebraic expressions to represent how many costumes and shoes were packed if there were 10 students. So if each student needed 3 costumes and 2 pairs, let's put that in a package, a little parentheses, because we need 10 groups of 3 costumes and 2 pairs of shoes. Now, they wanted to write 2 algebraic expressions to represent this. So the other way to do this, if you want to write 2 of them, is to is to basically multiply it out. 2 times 3c and 2 times 2p. So when I multiply 10, by the way, this is one of my answers. If I multiply 10 times 3c, I get 30c. And if I multiply 10 times 2p, I would get 20p. So that would be 2 ways of writing this. I could bring either 30 costumes and 20 pairs of shoes, or 10 sets of 3 costumes and 2 pairs of shoes. All right, let's do a couple more in the next section. Simplify the expressions below using distribution. All right, simplify using distribution. What that means is I need to distribute the answer. So do the double rainbow. 2 times y is just 2y. 2 times 7 now is 14. So you just plus 14 because there's a plus between them. Other reasons too, but that's it. Let's try another one. This one looks kind of weird. Number 13 looks weird because you're kind of doing it backwards, it seems like. But you're still going to, you're going to go this way, actually. 11 times 8k. Well, that's just 88k. Minus, now I'm using minus because there's a minus right there. And there are other reasons too, but, just keep it simple. And then 11 times 2, which is 22. So my answer is 88k minus 22. And that's our answer. All right, let's go to the next section. They want us to rewrite the expression by factoring out the GCF. So rewrite this by factoring out the GCF. So they basically want to do, make it look like the questions from above, or the expressions from above, like y parentheses 1 minus x. So in this case, they want us to factor out a number. What is a number that you can divide both 14 and 4 by. You could use the latter method to find the GCF, or some of you may already know off the top of your head. It's 2. Let's prove it. So 14 and 4, what can you divide both 14 and 4 by? Well, you divide them both by 2. 2 goes into 4 twice. It goes into 14 7 times. And there is no number that you can divide both 2 and 7 by. So our GCF is just 2. These numbers don't matter because we're not looking for the LCM, or least common multiple. Anyways, if you factor out 2, actually, I'm going to go ahead and write it right below here. You factor out the 2, and then you're left with 2x plus 7. And you may be wondering, where did I get this x from? Well, the x comes from here, that 4x. So if you already knew, the other way to do this is you could have just done this. 2 goes into both of them. You're left with 2x and 7. And then you would just, rewrite it as, oh, well, it's just 2. So yeah, 2 different ways of doing it. It's essentially the same way. And go ahead and try, it says 17 and 17, but really this should be number 18. Anyhow, go ahead and try the rest on your own. Good luck.